you will see we are now going to connect resistors in series and parallel, and going to analyze resistors in series separately and resistors in parallel separately. Okay, so first we will take resistors in series. What is meant by series connection? When one resistor is connected next to another, so like this it is connected next to the series connection, since there is no current division in that. So when something is called parallel, it means that there is some current division. Current is get divided. Here you see some amount of voltage is flowing. Due to this voltage, some current will be induced in the circuit, and that current is same in all the resistors. Okay, see this I is common for R1, R2 and R3. Yes, same I is flowing across R1, R2, R3, because there is no division for, there is no branch for current division. Only one branch like that. So only one current flows. If there is no current division, it means that all the things are connected in series. Okay, so here resistor R1, R2, R3 are connected in what? Series. This type of connection is known to be series connection. Okay, when the resistors are in series, the current will be same, but the voltage drop across each resistor varies. Okay, see some voltage is coming from here. There will be some amount of voltage, say called V1, will get dropped at R1. Okay, remaining voltage will flow to R2, and there is some amount of voltage again in R2 will get dropped, which is known to be V2. Every resistor has some voltage drop. Okay, when the resistors are connected in series, all the resistors have some voltage drop. The voltage drop in resistor R1 is known to be V1. Okay, the voltage drop in resistor R2 is V2. Resistor R3 is V3. So how much amount of voltage will be dropped? Say for example, I have 10 volt here. Totally 10 volt is coming to the circuit. Depend upon the value of this resistor, some amount of voltage drop occurs. So how much voltage drop will occur? It depends upon the value of the resistor. Okay, depends upon what? Value of each resistor. If I know the value of R1, R2, R3, I can find out the voltage drop V1, V2, V3. Okay, right? So now, so what is the total voltage? Say for example, some 10 volt is coming here. There will be some 5 will be dropping here, depends upon R1, 3 will be dropping here, and remaining 2 only there is no, that will drop across here. So all the voltage drop will be equal to the original voltage. So the sum of voltage drops will be equal to what? The original voltage, overall voltage. So can I write like this? Overall voltage is equal to sum of voltage drops. So say how many resistors I have in series, that many voltage I can add here. Okay, suppose this is only 2, then here I have 3 resistors, 3 voltage drops, so I have just added it. So sum of voltage is V1 plus V2 plus V3, right? So what is voltage? According to Ohm's law, V is equal to I into R, right? So when I replace V is equal to I into R, right? The voltage drop in first resistor is I into R. The voltage drop in second resistor is I into R2. Third resistor is I into R3. See, the voltage drop varies depends upon the resistor value R1, R2, R3, but the current remains same in all the resistors. So current is only I, not I1, I2, I3. Current is what? Same. Only voltage differs, resistor value differs. That is why I am putting V1, V2, V3, R1, R2, R3. Only I because of what? Current is same. Okay. So don't put I1, I2, I3 because current is same. Simply write that. Throughout all the resistors, see, same current flows. I only flows. Okay. So it is just current. So take I common, it will be what? R1 plus R2 plus R3. So according to the law, I can bring this I here, which is V by I is equal to how it comes? So just a small derivation. I know V is equal to I into R1, V1 is equal to V2 is equal to I into R2. Just add it up and bring this equation. Substitute 3 in 1, you get this. Substitute 3 in 2, you get this. So which means what? The voltage in first resistor V1 is what? Voltage in first resistor is equal to total voltage into that resistor value divided by two resistors value. Voltage in second resistor is what? Total value into second resistor divided by the total resistances. So this is only for two resistances. Only for this. Only if I have two resistances, I can proceed with this and find out the values of V1 and V2. So voltage divided, I can find using this equation what I can find? What amount of voltage divided in first resistor, what amount of voltage divided in second resistor. So that is why it is going to be what? Voltage divider rule. So you'll be getting a question in your assessment like total voltage is this, find V1, find V2. Which means what? You see the result resistor is in this, that we apply this value. Formula is find V1 and V2. Okay, right? So this when it can be used, if the total voltage is given, you are going to find out only the small amount of voltage what is divided in R1, use this. What is divided in R2, use this. Okay, right? So this is known to be voltage divider. Any doubt? So resistances we just added, brought like this, and again we substituted and brought like that. Okay? So this is what resistor in series and voltage divider. Would you want me to explain again? Shall we proceed resistor in parallel? Yes? So if I write resistor in parallel, this is same like both the circuits are same. See the circles, see? R1, R2, R3, same. The circle can be drawn like this. Which means what? Or in R3, there is a voltage V, some amount of current is flowing, which will get divided in first branch. Again, remaining current will flow, some current will get divided in second branch. Again, remaining current only will flow in R3. When the current is getting divided like this, which means what? The resistors are connected in parallel. So these three resistors are going to be what? Parallel resistors. Now I cannot just add the resistors. I need to use some other formula for this. You understand? Now the voltage is gone. See the voltage, whatever voltage is what? Potential difference between 2 points is known to be voltage. Voltage is what? Potential difference between 2 points. So the potential difference between this point and this point is V. Same potential difference here also V. Here also V. Everywhere it is V. Now the voltage is common. Current will get divided. always remember. In series, current is common in all the three resistors. Voltage only will get divided. That is why we saw voltage divider over there. Here what? Voltage is common. Current will get divided. So here we will see current division rule. You understand? Right? Now, just write. in 1. See, up to this is clear. Same. Whatever I told you, I1 is equal to V by R1, I2 is equal to V by R2. Since there are only two resistors, just add it. Take the common and taking LCM and getting it this. Okay? Up to this is clear. Now substituting 3 in 1 and substituting 3 in 2. First substitute 3 in 1. The place of V, you substitute I into R1 into R2 divided by R1 plus R2 into divided by R1 I have, right? So divided by R1. R1 will get cancelled. So I1 is equal to I into R2 divided by R1 plus R2. This is taken as equation number 4. You want me to explain again? I'm just taking B here. What is B from this equation? I into R1 R2. This bring this side. Divided by R1 plus R2. And take this as 4 or something. Substitute 4 in 1. Take it as 5 then. Substitute 4 in 1. Now it is clear. Can you able to understand anything or not? You are not clear. See, just I am taking I is equal to I1 I2. Right? The total current is equal to first current plus second current. What is first current? V by R1. What is second current? V by R2. Taking V common, it is 1 by R1, 1 by R2. So the total current is equal to this value. Now I don't want total current, I want individual currents, I1 and I2. Then what is I1? I1 is what? V by R1, I2. I2 is equal to V by R1. So how to find out I1 and I2? Since V I know, I should substitute V here, I should get I1 and I2. Okay? Taking V here, V na in the way, V condition I is equal to what? V is equal to what? I into R1, R2 divided by R1 plus R2. Take this equation, substitute here. In the place of V. The place of V is substitute I into R1 or R2 divided by R1 plus R2. And substituting here. Here I have already one R1. So R1, R1 will get cancelled. So I1 is equal to I into R2 divided by R1 plus R2. So now substitute 4 and 2 again. Now we substituted 4 in 1, right? Substitute 4 in 2. This is substitute 4 in 1. Substitute 4 in 2, what will happen? Same, we get I2. Substitute 4 in 2. What will happen? I2 is equal to IV is equal to I into R1 R2 divided by R1 plus R2 divided by R2. R2 will get cancelled. Okay, so I2 is equal to I into R1 divided by R1 plus R2. 5 plus 6. Clear? There R1 will cancel, here R2 will cancel. See, very simple. Just you are taking V common, substituting V individually here. From the one equation, substituting V in second equation, we are getting I1 and I2. You want me to repeat? Clear? See. So what is the current of current division rule says? The current in first resistor is equal to total current into second resistor value divided by R1 plus R2. You understand? So current in first resistor is what? Total current into second resistor value divided by R1 plus R2. What is current in second resistor? Total current into first resistor value divided by R1. Take voltage divider rule. Take your notebook. Turn it on. See the voltage divider rule. Same voltage divider rule says what? Voltage in first resistor is so total voltage into same resistor. Okay, current divider rule says that total current into opposite resistor. That is the difference. Okay, if you change this, your value will be wrong. Clear? Clear? So at the end, what resistance is We'll be getting what? R2 R3 plus R1 R3 plus R1 R2 divided by R1 plus R2 plus R3. You cannot just put R3 here, the formula will be wrong. Don't put R1 into R2 into R3 divided by R1 plus R2 plus R3. That will be wrong. Because this is the formula. Formula is wrong. There are three resistors. What is the formula? 1 by R1 plus 1 by R2 plus 1 by R3. You can straight away put calculator and find the inverse. Don't forget to take answer inverse. Otherwise, substitute take this, again take inverse. Okay, there are 4 resistors. You put again 1 by R2. Okay, in series there are n number of resistors. Just add 1. In parallel, how many resistors are there? That is 1 by R effective plus 1 by those resistances value. At last answer you should take what? Inverse. Don't forget, because this is 1 by R effective value. Clear? Clear? They will give you resistances in parallel and series. They will ask you to find out total resistance. Okay, right? Formula is clear? So we shall do a simple problem here. Yes.
1 by RF, we were something as resistance. As RF.
RF is very interesting. Don't forget the parallel. You substitute say 1 by RF is equal to 1 by 4, 1 by 5, 1 by 16. Last our answer no. In calculator there is one. Inverse no. Just inverse and take the answer. Inverse everything ana RF is value. Okay. We'll do problem if you understand. We'll do problem. Now, see, find V1, V2 and I in this circle. Find V1, V2 and I in the given circle. Do find V1 and V2. How to find out V1 and V2? Immediately when you see the circle, you understand who the resistors are in? The resistors are connected in series. Then how to find out V1 and V2? There is voltage divider rule. Just substitute voltage divider rule. Okay? Substitute voltage divider rule and tell me V1, V2. See, very simple this problem. Voltage divider rule says V1 is equal to total voltage into R1 divided by R1 plus R2. V2 is total voltage into R2 divided by R1 plus R2. You know the values of R1, R2, RP and all values we have. Just substitute.
Into R1.
Into R1. What coming? You understand anything? So total voltage is 20 into 5 divided by 10 plus 5. 20 into 10 divided by 10 plus 5. What is the value?
40 by 3.
No, I want that. Calculator don't have. We can put 20 into 5 divided by 15.
6.66.
6.66 volt. V1 is 6.66 volt. Is that right? 20 into 5 divided by 15. Okay. 20 into 10, 200 divided by 15 again. What? 13.3. just formula substitution. What is the current? Current is only one current, right? How to find out this one current? P is equal to I by P is equal to I into R. Then I want I, which is V by R. V value is 20 given in question. R is what? R is the total resistance, 15. So if this is the formula, you redraw this and the take total resistance as 15. Don't do in diagram because you have given video. You can draw separately. Draw separately. So it is what? 20 by total resistance, 15. Understand? 1.3 ampere. 1.3 ampere. See, sometimes they will give you only R1, they will ask you to find your R2, right? Whatever the question may be, you should use only one formula. If I have like this is 5, the voltage drop here is 13.3, V1, then R2. Now what are the unknown values? R1 I know, V2 I know. I don't know V1, R2. So first in this formula I can substitute 20 into 5 divided by, I don't know what is R. Just keep it as R1, 5 plus R2. So I need some values over here. These are the values. So substitute this. Just say whatever it is asked. R2 now we need to find out. Again take this formula. Substitute V1 here, 6.66 is equal to 20 into R1 is 5. 5 divided by 5 plus R2. Okay, 5 plus R2 is what we will do. Last 5 minus R2. Okay, so whatever is unknown value, if you see something like this, take this formula. Whatever you can substitute here, you get unknown value. Okay, right? Don't accept always R1 and R. Okay, ma'am? Clear? This formula is very, very important. Okay, ma'am? You will take simple circuit and current guide you. You are going to prove it. I am not going to guide you. Just take this circuit. So take it as 12, 10. Find I1, I2. This is 12, this is 10. Find I1 and I2. In order to find I1, what do you want? What is current divided? It says R2 total current into R2 divided by R1 plus R. What does I2 says? Total current into R1 divided by R1 plus R. In order to find I1, I2, what I want? I want I1 and I2. So what are the remaining values I need? I want V, I don't want actually. V is there in the formula? No, but the question only V is given. I want I, total current I want. How to find out the total current? Total current is given in the question. No, mostly they won't give current. Rarely they will current. They will give current. Voltage only they will give. Then you should be finding current. Okay, what is formula for finding current? I is equal to V by R. Now I need to find out the total voltage. Sorry, resistor. Voltage is 100. In the place of R, what will you substitute? The effective resistance value. So on that place you use 1 by R effective. Here it is one, not only R, it is R effective, total resistance. Because I have two resistances. Then it is 1 by R effective is equal to 1 by 12 plus 1 by 25. The total current is I is equal to sorry resistance is 100 divided by 5.45. Now you will get the total current. Now you substitute the current here, find out the current. This is not 2-mark problem. Very simple problem. Whatever the question comes, see remember, you see resistor in parallel, directly write this formula first. Write this formula first. And see what are all the values are given. What you need. Voltage is given, but you need current. It does not need voltage. So from the voltage, how to find out current? Using this formula. Okay? Again, you found out current here, substitute here and find out current. Clear? This is 18.3 ampere. Remember the current you will get should be addition of this. If it is not addition of that, then there is something wrong in your calculation. I1 is 18.3 into R2 10. Okay, ma? R2 is 10 divided by 10 plus 1. I2 is 18.3 into 12 divided by 9.98. Okay, ma'am. I2 is what? I2 will be 9.9. If you add I1, I2, you are getting this 18.3. You can make it plus 8 plus 9 plus 9 is 18. There is 0.9. You will be getting around 18 point something. So it's like, okay. Any doubt in the problem? Yes? 18.28. Okay, 28 is approximately equal to 18. See, if you add I1 and I2, you should get this total current. Okay, that is just to cross check whether you have done it correctly or not. Okay, right?